In part 2 of the Anthropogenic Change lecture series, we're going to talk about projections, what we think is going to happen in the future based on what we know about what's going on in the present and what we've observed in the recent past. Now, when we talk about scenarios, we're talking about different possible outcomes based on our action at this time. In scenario A, here, we're assuming a continued reliance on fossil fuels to power our economy, power our lives, our homes, our vehicles. In scenario B, we're assuming that carbon dioxide concentrations are going to level off or stabilize in the second half of the 21st century at around 600 parts per million. So this is twice the pre-industrial level, but it's about a little less than 200 parts per million higher than we are today. So we've already gotten most of the way there, or a good part of the way to 600 ppm. And lastly, scenario C, in the blue line, or represented by the blue line, we have a peak of carbon dioxide concentrations at around 2050, followed by a significant but not overwhelming decrease to near present level by the end of the century. The present level being 400 ppm for 2018, 420 ppm for 2020 or so. So taking a look first at 3 different scenarios. Again, we have no change. We just keep doing what we're doing. We end up in scenario A with a much greater temperature change than we've observed already. A 1 degree increase in the last 100 years. This is projecting a 4 degree or more total increase by the year 2100. Scenario B, where we start cutting back significantly, we can end up with a temperature change of about half of scenario A, where we let things run wild. And in scenario C, where we start a dramatic cutback right now, we can see that we can stabilize the temperature at approximately the unsustainable temperature that we're at right now. So when we look at average surface temperatures, scenario A being the worst case scenario, temperatures are increasing out of control essentially. And particularly at the high latitudes, all bets are off as to how warm it would get. Some models predict a change of up to 12 degrees. So essentially turning the Arctic into the mid-latitudes. All the Arctic ice would go away under this scenario at the northern high latitudes, and much of it would start decreasing at the southern high latitudes. Scenario B, bad, but not as bad. Scenario C, best case scenario, is still not very good, but it's much better than hopeless, as in scenario A. And this gets back to us, what we're doing. Part of what we're doing is just multiplying. There are more and more people all the time. The population has essentially doubled since I was born, and it's going to get much worse before I die, unless that's very soon. And that is going to entail an energy usage. Every person that's born is going to need stuff. You'll need minerals, you're going to need food, you're going to need fuel, you're going to need space. And it's this rise in human population, the increase in that population size, that's increasing anthropogenic emissions. What we see here are different models of population growth that are used by the IPCC. Scenario A, we're not going to see a leveling off of the population until 2100, about 80 years from now. Scenario B and C, we see a leveling off of the population at 2050, so roughly 30 years from now. And in scenario C, we see a decrease in population beginning shortly after that. So best case scenario here is scenario C, where the population starts to go down. What are the implications for us? Well, the implications of climate change are numerous and dependent upon where you live and what kind of environment we're talking about. Models predict increased humidity and frequency of heavy rain, more intense and longer droughts. We've observed that in Australia, which led to the bushfires, and in California, which has been suffering from a 10-year drought. Now, both of those droughts are over. In the case of Australia, we have extensive flooding. So we've gone from the dry bushfire years to flooding. And you may have seen reports recently that this has led to an outbreak of spiders and snakes. Basically, all the animals that live underground are forced to flee their burrows and get to the surface where they can breathe. So it's not really an invasion of spiders or snakes. It's just that you can see them now. Included amongst these changes in weather and climate are widespread changes in temperature extremes. We're going to have more extreme hot periods and perhaps more extreme cold periods. We're going to see increased hurricane activity in the North Atlantic. We've already seen that. We've run out of names for storms now. In the Pacific, we're also running out of names for storms. These changes include a decreased amount of sea ice. We've already observed that. Here we see the long-term median ice edge from 1981 to 2010 in red. You can see the offset here, this gap, and here. This is ice that's no longer where it used to be. We see increased incidences of property damage due to melting of permafrost. Whole towns and villages at the high latitudes are now being destroyed by the ground melting, simply melting, and destabilizing anything that's built on top of them. And we can see the retreat of valley glaciers. This is the Bergsdal Glacier in northern Norway about 10 years ago. I suspect it's retreated further since then, and that's going to continue until the glacier's gone, perhaps in another 100 years or so. So here we see another image of the decrease in sea ice from September 1979 to September of 2012. An area the size, much larger than the size of many countries, is now open water. As you can see, this surface is white and shiny, reflects incoming radiation. It doesn't get a chance to become blackbody radiation, whereas anything striking this dark blue surface will tend to get absorbed. It either goes directly into warming the upper layers of the water or bouncing back as blackbody radiation. Either way, this is much more of a solar insolation sink than this is. So we're changing the color of the Earth. That's a pretty substantial thing. Decreasing sea ice is going to disrupt habitats for Arctic animals. In this case, we see the iconic image of a polar bear with a cub. We look a little closer. What these bears are doing is looking for food, obviously. And they do this by watching the water. They're eating seals predominantly. They're coming up for air. When the seals are underwater, they're feeding on fish predominantly, but those fish are feeding on diatoms, algae that live under this ice. So as we decrease sea ice, we decrease the opportunity of these bears to be polar bears, to spend their lives feeding on the ice. We also decrease the whole food chain. The whole bottom of the food chain gets pulled out from underneath these animals. And that's seen here. These are diatoms living under sea ice. In this case, it's Antarctica. And this is one of the studies we've done in Antarctica on changing diet. So essentially, diatoms live under the ice. Krill, little shrimp-like animals, eat the diatoms. The krill are eaten by fish, and in this case by penguins. Fish that eat the krill are also eaten by seals, both in the Antarctic and the Arctic, in the case of the polar bears. The difference here is the penguins have no fallback plan. The Adelie penguins have been reduced in population size by 50 to 70% in some of the Antarctic Peninsula rookeries. Chin straps are doing okay because they don't rely so much on krill that's relying so much on feeding under the sea ice, so they're not as impacted directly. Polar bears, however, are impacted directly because as the diatoms decrease, the krill decrease, the fish decrease, the seals decrease, the sea ice that the bears wait on decreases, and the bears are actually turning to more terrestrial diets. They're eating snow goose eggs, which are basically like eating a stick of butter nutritionally. Sure, it's fatty, bears need the fat, but they need more than just the fat. So we've been measuring polar bear bum hair samples, take a little snippet of hair off their rump here when they're tranquilized, and we bring those back to the lab along with a little toenail clipping. We analyze those for the isotope values, and we're able to constrain the diet of these bears over their lifetime. We also see a retreat of valley glaciers. In this case, Boulder Glacier in Montana. It used to be a famous glacier. It's now retreated to basically a summer snowpack. This is all going to be gone very shortly. It might be gone now. I was there a couple years ago. I remember seeing some patches of snow. It was early in the year, so take that with a grain of salt. Sea level is predicted to rise by a meter or so during the 21st century. Within the next 80 years or so, we'll see sea level come up a meter. This is going to flood low-lying countries and islands. Micronesia, the Pacific Islands in the Western Pacific, are pretty much doomed. They're basically right at sea level today. They're made of corals, after all, corals and algae. And if sea level comes up at all, they're going to be the first to go. And anybody that lives there is going to go. We're going to see increased storm surge and flooding during storms. Low-lying places like this are going to be much more susceptible to storm surges and flooding associated with storms off the coast here in the Bay of Bengal and onshore here in places like Bangladesh, which you see here in this image. Bangladesh is particularly vulnerable to sea level rise for a number of reasons. Two of the big reasons are the Ganges River and the Brahmaputra, which is called the Padma in Bangladesh itself. The population of Bangladesh is 161 million as of 2018. Its area is 148,500 square kilometers or so. That is roughly 26 times the size of Prince Edward Island. So we have something that's 26 times the size of Prince Edward Island with many, many times the population of all of Canada, crammed into a fairly small area that sits right at sea level. So all of this area here is a meter or so within sea level. Any storms that push water in are going to flood this region. Any floods due to heavy snowfall out of either India or China, the Himalayas, is going to result in flooding from the rivers. This led to the Concert for Bangladesh in 1970 by George Harrison. If you're too young to know who George Harrison is, he was with the Beatles. The Beatles broke up in 1970, immediately got into independent projects, and one of them was George Harrison and Eric Clapton, Ringo Starr, a bunch of other famous musicians at the time, got together to raise money for the people that were flooded and displaced in Bangladesh 50 years ago. One of the problems we have with sea level rise is it's very hard to measure sea level rise. You need something that's stable at one position vertically for a very long time. One thing you should get out of the class so far is that nothing stays the same for a very long time. Things are moving up and down, back and forth, in and out, all over the place, all the time. That includes sea level rise or sea level fall. And again, scenario A, unmitigated change in our behavior. We're going to see sea level rising more than a meter by the end of the century. If we do everything we can to stop sea level rise, we're still going to see a sea level rise of about a half a meter. That's going to displace who knows how many people from Bangladesh alone. 40 million, 60 million, 80 million from that country. That doesn't count the other 193 countries or so. Countries like this are going to be the first to suffer. These people are going to be displaced. They're going to have to go somewhere, and that means somewhere. Numerous species will lose more than half of their habitat by 2100. So we see a negative effect not only on people, cities, our low-lying countries, we see animal habitat destroyed. We can see here the historic wolf range for the United States is now contracted to a couple little areas. Now, when you say this is wolf range, that means there might be a couple here and there in these large red areas. You're certainly not going to see them driving around on the interstate. And same goes for down here. There are little spots of habitat remaining in these areas. So we've gone from a very large range to very constricted range. Same with grizzly bears. They once ranged all the way from the Arctic down to central Mexico, close to Guadalajara. They've been contracted by habitat loss and by hunting, just like the wolves. In Africa, it's perhaps even more severe. We can see the historic elephant range with a population of 27 million, reduced to a current population of around 500,000 and a drastically reduced range. And in these ranges that remain today, they're still hunting, they're still poaching, and elephants are still threatened, very much so. Coral bleaching, another human invention, started in a big way about 50 years ago or so. This is typical now when you dive on many reefs around the world. It's totally devastated, lost its color. The reason its color is gone is there are little algae that live in the corals called zooxanthellae. When these zooxanthellae get stressed, they leave. And once they leave, the corals don't get the food source that those algae provide to the coral. The corals protect the algae, and in return, the algae give the corals a little taste of the sweet stuff, the sugar. So this brings us to a table of stuff that's going to go wrong. Potential effects of climate change on ecosystems and resources. In forests and other ecosystems, we're going to see a migration of vegetation. It's going to go to where it's happy. It needs more water or less water. It's going to go to where that situation is. Higher or lower temperatures, again, it'll follow that situation, that ecozone. There's going to be a reduction in ecosystem ranges. Regardless, we're punctuating them. We're chopping them up. We're introducing farms and cities in between former wild areas, and we're altering the ecosystem composition. We kill the wolves, we kill the grizzly bears, and then we wonder why, hey, there are a lot of deer now. Species diversity. We're going to lose enormous numbers of species. It's been suggested that we're in a modern mass extinction, and you can certainly argue for that. So loss of diversity, species are going to migrate to find the environment they need or they prefer, and we're going to see them replaced by new species. You've probably seen video of the Asian grass carp situation in the Midwestern US. They're taking over ecosystems, and they do some crazy things when boats get around them. Anyway, coastal wetlands, we're going to see wetlands subsumed by rising sea level. And again, we're going to see migration of wetland vegetation. It's going to move to where it's best suited. Aquatic ecosystems, more loss of habitat. We are removing the fish from reefs around the world, and we're killing the reefs on top of that. So they're not going to come back for a very long time. Animals in the oceans will move to new habitats if possible. And again, we're going to see invasion of new species. Crown of thorns starfish invaded the Great Barrier Reef decades ago and destroyed much of the reef. Coastal resources are going to be inundated by flooding and storm surges, wind from tropical storms and subtropical storms. Water resources, we already see a change in water supply. Changes in patterns of drought and flooding and changes in water quality are all going to be things that we're going to need to wrestle with to survive. Agriculture, we're going to see changing crop yields. That's always the case with agriculture. Shifts in relative productivity among regions. Some regions are going to benefit, some are going to suffer. Human health is going to face a change in ranges of infectious disease organisms. Tropical and subtropical organisms will move to the higher latitudes. Things like Zika virus that wouldn't have normally been a problem here. West Nile, things like that are coming from places far away with very different climates, begin to affect us in places like Saskatchewan. There will be changes in patterns of heat stress and cold weather afflictions, problems that people have with hot weather and cold weather. And of course, energy. There's going to be an increase in cooling demand as temperatures rise, a decrease in heating demand as temperatures rise, at least at the lower latitudes, and changes in hydroelectric energy resources. A few years ago, I rode through along the Trans-Labrador Highway to Churchill Falls, and Churchill Falls is called Churchill Falls because there was a waterfall there, and now it's pretty much a small stream dripping over a cliff, much like the waterfall I showed you in Mexico a while back. The highest waterfall in Mexico, which is dropping about 3 gallons of water a minute or so. So that's going to affect hydroelectric energy resources. Reduced precipitation, where people are relying on water for energy, is going to result in less energy.